All right, welcome to the video on ionic compounds. We're going to be getting started on these, and I put down a hard and fast rule for ionic compounds. An ionic compound is always made between a metal and a non-metal, or a metal and a polyatomic ion. There's going to be one exception to this, and there's always one exception in chemistry. That's the only constant. So this is important. This is our hard and fast rule. If it's got a metal, it's going to be an ionic compound. Now, some properties of ionic compounds are, one, they are brittle, and we're going to find out about that in a minute. And two, they have very high melting and boiling points. The bonds in ionic compounds are very strong, and so they stick together very strongly. Because of that attraction, it's very difficult to break them apart, which is what you're doing when you boil something. So on to the ionic bond. An ionic bond is a very simple thing to understand. It's an attraction between oppositely charged ions. That's what they do. If you have a negative ion and a positive ion, they attract, boom, they're stuck together. Very similar to magnets or magnetic ends. So you have plus ion, I'm just writing A, there's no element that's A, and B is just the second letter in the alphabet, that's it. So you have a positive and a negative ion. This is what we call an electrostatic interaction. These are two charges that are not moving that attract each other. This is our ionic bond. And it's set up like this. Hopefully you can see it in the video. I have plus, minus, plus, minus, plus, minus, and I have a grid of that, all right? So when we talk about an ionic compound, what we have is this grid of ions, all right? And when we have this grid of ions, they set up nice and geometrically like that. That's why when we go to Washington, D.C. and go to the Natural History Museum, I will request that you all go to the Hall of Gems, because you can see all these geometric shapes that ionic compounds form in nature. Very, very cool. Well, one of the reasons why ionic compounds are brittle is if you take, this is my Thor's hammer here that we are going to whack that part of the ionic compound with, this line down the middle is an attractive force right now. You can see we have a positive and a negative, etc., all the way down. As soon as you hit that, what you do is you shift the ions. And when you shift the ions, all of a sudden you get positive next to a positive, negative next to a negative, so on. When we have like charges next to each other, they repel. That's why I wrote repel here down that line. And so they will break apart. So when you talk about an ionic compound being brittle, if you hit it with a hammer or drop it on the ground or something like that, what you're doing is you're shifting the lattice of ions. So instead of having these attractive forces, they have these repulsive forces, and it only has to happen for an instant. So it's not something that has to be maintained over time. So this is our introduction to ionic compounds and their properties.